Sure. So I'm going to repeat, I just gave a little bit of an explanation of what we did in the previous class, and especially going through the different graphs, the frequency distribution. Ay, Dios mío. So the frequency distribution table, the graphs that we built, the scatter plot, I like this very much. You are going to find, if you are taking econometrics, many of these computations have to do with the linear regression. So this is kind of like the basis of the basis of the linear regression. This is the equation that you can build for that purpose. So Excel does it in a very simplistic way. So also time series, if you are an economist, basically you have to deal with time series. So I was mentioning too that if you take, well, you have to take econometrics, and I hope you take the class with all your enthusiasm, because it's a very good class. So, but anyways, so today we are gonna spend little time talking about the location and central tendency measures. So, and the most important of them is the mean. Every time you have data with you, the first thing that you are interested on is knowing the mean value, the average of that data points. For example, if I have the all my grades, I don't care for the grades, I care for the mean value. If I, well, most of the data, the most important value that we can compute is the mean. So the mean is the sum of all data entries divided by the number of entries. So in this formula, population mean, so mu, as you remember, is a Greek letter, is a parameter. So this is mu is the population mean, and we're gonna find the population mean by adding all the observations. So this sigma notation means addition. So if you remember, we have something similar here. So this is the sigma notation. So that means the summatory. So we are gonna add all the values. And in this case, because it's the population mean, we are gonna divide it by the population size. But we also can have a sample that, of course, a sample is a proportion, is a segment of this population. So remember, it's not very easy for us to do studies in populations. Most of the work that we can do refers to the sample. So if we have a sample, we can find the sample mean. So this sample mean is basically the same, but in this case is a statistic that is identified as X bar. X bar means sample mean, also the addition of all the data points divided by the sample size. So we have a very easy way to do it in Excel. So we can do it by hand. I'm very lazy, I can tell you. I like to use Excel. So what we're gonna do in this case, so we are gonna find the mean. So let me make this bigger, and please don't hesitate to remind me that I need to make things bigger. So in this case, we have different ages. Let's say this is ages from some place. So I ask people how old they are. And for example, this is individual 1, 2, 3. So I'm gonna assume that all these people are part of a group. So here I have 29 people, right? So I go ask their ages to 29 people, and those are the answers. I already organized the data from the lowest to the highest. When you are using Excel, most of the times you do not need to arrange or filter or sort the data. So Excel can perform any computation with the data as is. So in this case, I think the database already was organized by So from the lowest to the highest. So as I mentioned before, so in order to find the mean, so I'm gonna type this command, right? It says equal. Remember, all the functions, all the formulas always start with an equal sign. Then I'm gonna type average, and I'm gonna highlight all the data points. So that's what array means. So I'm gonna say for the mean, I'm gonna say equal average, open parentheses, and then highlight my information. So I don't care for the other line because I am just naming the individuals. I can say Juan, Pedro, Janet, but in this case, I'm just giving them numbers, right? So I'm gonna make sure that the parenthesis is closed, and I am gonna type enter. So that is the mean age from my population or from my sample. So in this case, we have to be clear what we are talking about, because if this is the population, this is gonna be the population mean. But if this is only a sample, I am gonna have only the sample mean, right? So we have to be very clear. For example, it doesn't, the idea of population and sample doesn't mean it has to be extremely large, the number to be a population. For example, if you want to know the ages of all the professors at Lehman, well, there are not too many. I guess we are not more than 500, right? So that will be the population of professors at Lehman College. So if you want to take CUNY as your population, so now all the professors at CUNY, I guess, I don't know, I'm just gonna guess like 50,000 people, or I don't know, not 50, 5,000 professors. So that's gonna be the population of the entire college, okay? So once again, to compute the mean, I said equal average, open parentheses, I highlight, so I'm gonna do it again, average, open parentheses, I can click in this. So some people are good at using fingers to highlight areas. Some people are not. So what I do is I click on shift and then I click the arrow up. So in this case, I am sure that I am gonna be highlighting the data that I want. So, and at the end, I just add the add the parentheses. So that's gonna be the mean. So in this case, is the sample mean. Let's call it that way. So we have the sample mean, the population mean. So also another important measure of central tendency is the mode. So the mode is the data entry that occurs with the greatest frequency. And if there is no entry, if no entry is repeated, then there is no mode. In some cases, we have more than one mode, and our data can be called bimodal. So to do the mode is also very easy. So the mode is going to be equal. It's going to be equal mode, open parentheses. I am going to click in shift and hold it, and then move my arrows up. I'm assuming that there is no mode here, but I don't know. Sometimes these databases are so big that it's very hard for me to identify. So if I press here, it says enable, so there is no mode. So no number is repeated at least more than once. So so that is the mode, is the number that is repeated with the greatest frequency. And once again, if there is no repetition of numbers, there is no mode. If there are 2 or 3 modes, it can be possible that we have more than one mode. So in many cases, we might have 2 modes. Those numbers are repeated in the same way, and those happen to be the highest. So also, we have the median. So the median, you can do it by hand, and as far as I can tell you, you get a very quick result using Excel. So the median is a number that measures the center of the data. For example, as we can see, 48 is the mean value. But if I divide this, we have how many? We have, so last time we use equal count to know how many elements we have in this database. So I'm gonna see how many elements we have in this database. We have 29. So so the observation 14, so 14 and 14, observation 15, because this is a odd number. So let me read this first. So the median is a number that measures the center of the data. So it's not the point that summarize all the values, but it's the point that is exactly and physically in the middle of the data set, when the data set is ordered from the lowest to the highest. So half of the values are the same number or smaller than the median, and half of the values are the same number or larger. So in this case, for example, we have 29 observations. So that means that observation 15. So we have 14 on top, 15 on the bottom. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, and 15. That should be the mean value, right? Sorry, the median value. So in this case, we have a median value that divides my my data in two different segments.
Professor?
Yes.
Should be 47.
So that's the 15 observation?
Yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. You are absolutely right. Thank you.
Well,
that means that you are paying attention. Thank you very much. And to be honest, I was just testing you guys. No, just kidding. I made a mistake. So, and I made a mistake because I'm not good at using at doing this physically. So technically speaking, oh yeah, of course, it's the 15. So it's the entry 15. So I have 14 on top and 14 on the bottom. So if I have, well, there is a rule, odd numbers of entry, the median is the middle data entry. So in this case, we have 29. So the middle is gonna be the number exactly in the middle. And if we have even numbers, let's say we have 30. So I have to add all these two numbers and find the average of those. So the median, when we have even numbers, is the mean value of the two middle data entries. So if I have 30, so 15 and 16 are gonna be, so the ones here, and the median is gonna be the average of these 2 points. But also we have this Excel function is called median. So surprisingly, it's very easy to do. So I'm gonna ask Excel to find equal median, open parentheses. Once again, highlight all the information, close parentheses. So I have the median. So, and this is important. This is very important because you might say, why do you need two different values? Why do you have the mean and then you are computing the median? Well, in many cases, the mean value is affected by different numbers. Just imagine that in this case, we have a person that lives 1,000 years, right? So as we can see, the mean and the median are changing. Well, the median is not changing, but the mean is changing a lot. So what does that mean? Well, what means is that the mean value is always affected by the presence of outliers. So in this case, it's very clear that 1,000 is an outlier. So that's the reason it's affecting the value of the mean. So in many cases, for example, if you are accounting for income, income basically is always unfair. So you have, like, for example, if you are measuring income inequality in New York City, of course, you have people like Mr. Bloomberg who makes millions, billions, and quadrillions of dollars, and people who do not have jobs and they live under government assistance. So this disparity of income, of course, is going to be captured by the mean, but the median is going to be more representative of our values. So it depends very much what is the goal, what is the nature of the data. So in this case, my point here is that we have values to compute, and you can make the judgment which one is the one that you want to analyze. But the goal of this is that you use Excel to do the computations. So anyways, so we have the median. So we have an Excel function for the median. Also, we can, so as we saw here, so we can separate the data. Here we can separate the data in 2 parts. But the question is, why not to separate the data in 4 parts? So I'm gonna cut my data in halves, and this half, I'm gonna cut it in half. So I'm gonna create 4 different quarters, right? So we can use the quartile approach. So quartile is a number that separates the data into quarters. So 25 of the data, 25 of the data, 25, 25. So we have 4 different quarters. Quarters might be or might not be part of the data. So in some cases, the number I'm looking for might not be here, but that represents the first quarter, the second quarter, the third quarter. So you can do it by hand, but that is not what we are gonna do today. So we are gonna do 2 exercises regarding this case. So I'm gonna find the quartile 1, quartile 2, quartile 2, quartile 3, quartile 4, okay? So how do I do that? Well, we have an Excel function that can be used for that. So I'm gonna ask Excel to find the quartile. I'm gonna highlight the array. So so the database I want to find the value for, and then I'm gonna indicate Excel what is the quartile that I need. So you need to see also what kind of Excel version you have. So in some cases it changes a little, but changes are not very or the difference are not very strong. So in this case, in all likelihood, you have the quartile and then open parentheses, and as you can see, it's asking for the array. So I'm gonna highlight all my information. So make sure that you include only the information that you need to include. So in this case, I'm gonna use a comma, and as you can see, I don't have to do almost anything. Excel is telling me, what do you want? Do you want the first quartile? Okay, sure, and I'm gonna do that. And then I close the parentheses. So we have the first quartile. So in the first quartile, so this is Q1. So Q2, surprisingly, Q2 is the median value. So I'm gonna say equal quartile, open parentheses. Once again, I'm gonna highlight all my information. I'm gonna type a comma. I'm gonna ask for this 50%. So as you can see, the 50% is also the value of the median value, okay? So we close parentheses, and then we have quartile 1, quartile 2. As you can see, this is quartile 2. We also computed this with the value of the median, so it's 47. So we are right. we are gonna compute quartile 3, Q3, sorry, quartile, open parentheses, once again, oh, well, I don't like this. I was using my comma and then quartile, or I can even type number 3. So this is the quartile 3 I want. So so we have quartile 3, and then I want the quartile 4, quartile open. So we, as you can see, we computed the quartiles with no problem whatsoever, right? Quartile 4. So, and the quartile 4 happens to be the highest value, okay? So, so we can use the quartiles. Quartiles are very helpful, very easy to understand. So once again, you are analyzing, for example, income. Income is very likely to be, so is affected by the mean value, okay? So something that we can do with this information, hold on, there's some questions, I guess. Professor, will you record? Yes, yes, yes. Okay, yes. The session is being recorded. So it is, right? Yeah, it's recorded. So something that we can do here also is the following. So we can use something that is called the box and whiskers. I'm just gonna do it once so we can discuss this in a bit in few more minutes. So what we're gonna produce is a graph that is called the box and whiskers. So you are gonna see insert chart, and it says box and whiskers, okay? So keep in mind this, we're gonna be discussing this chart. So basically what we have here, this is quartile 1, as you can see. So the first bar of the box is quartile 1. This is the beginning of the data, right? So this is the lowest point. So this is quartile 1. This in the middle is gonna be the quartile 2, which happens to be the median value. And then we have quartile 3, and then at the end, we have quartile 4, right? So this is gonna be very helpful because when we are analyzing this graph, well, we can see that this graph is very nice because the median value is basically somewhere in the mean of this graph, right? So one of the cases is that these whiskers can be very long, either one. So that probably means that there are some outliers. So let me make this, and that's the reason I like Excel. So just imagine that we have, as in the previous case, 1,000, a person who lives 1,000 years. So in this case, as you can see, my mean value changed, and my values changed also here. As you can see, we have a first quartile, second quartile, third quartile, they didn't change. Or quartile 4 is telling me something is happening here. It seems to be that there is a number that doesn't fit. Well, the question in this case, is that true that a person lived for 1,000 years? Well, probably I made a mistake, and instead of saying 100,000, sorry, instead of saying 100, I said 1,000. I mistyped my data. So we can still see that this whisker is a little bit longer than the other one, right? So that means that the lowest value is very likely, the highest value probably might be an outlier, right? So that's what we can say. So, and there are many things that we can do with these quartiles. For example, we can find the interquartile range. So that interquartile range is the number that indicates the spread of the middle half or middle 50% of the data. So we are gonna find the interquartile rate, range by subtracting Q1 from Q3. So once we found this value, so the interquartile range can help determine potential outliers. So a value is suspected to be a potential outlier if I multiply 1.5 times Q1 and the value is less than the value I found. So, or if I multiply 1.5 by Q3 and the number happens to be larger above the first quartile, so that means that those are outliers. So I built these cases in another example. So we have the quartiles here in one of these cases. Oh, I think I did it, right? That making me crazy. Okay, let me put this somewhere in here. So where I was, scatter plot, time series, location. So is that the same database? I guess yes. So we already found this equal quartile. And should I do all of them again? Array. So 2 is going to be also quartile, open parentheses, comma 2. I'm going to do equal quartile open parentheses, so comma 3, so quartile 3. So in this case, I am doing here quartile 4. So we need, this is the interquartile. So let me make it bigger. You zoom. So I produce the same values as before. So remember the Q, the maximum is the last quartile, right? Quartile comma 4. So we have all the values, right? So we stated that the interquartile range is going to be the difference between Q3 and Q1. So here I have the difference between Q3 and Q1. So is 37, right? So the rule says, so the rule says here, so the rule says here, if less than 1.5 times interquartile before the first quartile, below the first quartile, or more than 1.5 times the IQR above the third quartile, then those are potential outliers. So what I did here is I multiply 1.5 times 4, so it was 45, so it's not below 30. So that means that there is no an outlier in the bottom of my data. But I did it for quartile 3, and the number is higher than this. So it seems that there might be an outlier in this database, so which I don't get it very much. But so according to this, we are. So this is 1.5 times D6, yeah. So the number is clearly higher than quartile 3. So more than 1.5 interquartile above the third quartile. So that means that that there is an outlier. So so below this, so in the first case, less than 1.5 times the interquartile range. So we got 45, and this is 47. Oh, okay. So this is less than. So in the two cases, this number is below the first quartile, this number is above the third quartile, so that we can use it as potential outliers. So, so probably the median, the mean might be very helpful for us to determine that is or not a outlier. So we have this example. I guess I didn't use that example, but you can do it. So you can look at these values and you can do the same test and come up with a very good answer. So just by looking at the data, it seems that 5,500,000 is an outlier. So most of the houses are in between some range, but this number happens to be very high. Probably that might be so the case for an outlier. So a potential outlier is a data point that is significantly different from other data points. So these special data points might be errors or some kind of abnormality, or they might be a key to understanding the data, right? So in some cases, the presence of outliers can be some good information that we need to make an interpretation on the nature of the information. So also something that I want to mention is that we can find the percentiles. So in this case, we divided the data in four cases, in four different groups of 25% each group. So we can divide the data even more and find percentiles. So we can divide this data in percent. So we can find 100 different percents in this. So a percentile indicates the relative standing of the data when the data is sorted into numerical orders from the smallest to the largest. So we have an Excel function to find the percentile. So as we have the one to find the quartile, so we also can find the percentile. So so in this case, we also have a formula. I think I did the two of them. I am using the formula where I is the index, so the ranking of the position. The K is the percentile, and N is the total number of the data. So I want to know what is the percentile in, like, what data represents the 70% of the data, right? So in this case, what I did is the following. I use equal percentile. I did the range, the array, comma, and I want the 70%, right? 0.7. So that is gonna tell me which number in this data represents the 70% of the data, the 70th percentile. So in this case, 63.2 is the value that 63.2, somewhere in here, that represents the 70th percentile. So with the formula, what we are doing is that this formula is telling me which of the numbers, what is the position that represents the 70th percentile. For example, I am using this formula, K over 100 times N plus 1. So where K is the rank. For example, if I want the 70%, so it's going to be 70 over 100. So times the sample size plus 1, right? So in this case, that's what we did here. So I am asking this, for example, in this case, we have, so we are building a formula, and this formula is going to be equal 70 over 100 times, so is is 29. In this case, we have 29 positions plus 1, right? So I'm always trying to maximize my computations. I always use parentheses. Sometimes they are not needed, but I always do. So in this case, this formula is telling me that the 70th percentile is represented by the 21 number, right? So, so in this case, so I have the 21 that happens to be 64. So Excel gives me a more accurate number of the 70th percentile, whereas the formula points me in the data what is the position that is the percentile. So we also have here the 83 percentile. So I am asking Excel, once again, percentile, open parentheses, highlight my data, and I want I said 83, right? 0.83, close parentheses, okay? So, so the 83rd percentile happens to be 71.24. So it's also 71.24, something like this. So in this case, I guess because the number, so the rule says if you have an integer, you use the integer. If you have a number that is has a decimal, so you do the 24 rounded down and then rounded up, and then take the average. So the number that I am gonna use is gonna fall between 24 and 25. So here is gonna be my 83rd percentile. So that's what this formula is telling me. So once again, Excel gives you a more accurate value for percentiles, right? So I want to know what is the 80% of the data. So for example, if you are doing tests, the SAT, and you see the values that you got in your test, so you are wondering whether you will be accepted to MIT or probably to Yale, because those schools are accepting people that are above the 95th percentile. So you can see your score and see, oh yeah, I am in the 95th percentile. Probably I should apply to one of these colleges. So so this is not. So this is the so let me close this once and for all. So we have the percentiles, and this is the formula to finding the kth percentile. So we can use the formula, this formula, and remember, if it's a positive integer, so you use the ith value for this in this data set. So in this case, we found out that according to the formula, position 21 represents the 70th percentile. In this case, when we are doing the 83rd, we happen to have a number that is not so has a decimal. So you round it up and then down, and then take the average of the two, and that's going to be the value that represents my my 83rd percentile. So in this case, my 83rd percentile is going to be 71.5, but because I am using Excel, I'm getting a more accurate number. So also, we have some other cases. So I did this part. You can, you can do the 20th and the 55th percentile. So so here we have also formula for finding the percentile of the value in the data. So so you might be wondering what is the percentile for 58? Well, I don't know. So I'm gonna find the percentile for that particular value. So the book is suggesting a formula. So, so we have to order the data from the smallest to the largest, the number of the data values counting from the board X. In this case, X is going to be the number of data values counting from the bottom of the data, list up to, but not including the value for which you want to find the percentile. For example, in this case, there are 18 different positions before 58, right? So that's what I'm going to type here. So there are 18 different positions between 58. So that is going to be the value of X. Y is the number of times that number appears in my database. In this case, just one. And then N is going to be the number of the sample size, right? So it's going to be the sample size. So if I compute this, so very likely my number is going to be, so it's going to be in the 64th percentile, right? So, so 58 represents the 64th percentile. So, so then round up to the nearest integer. So, so that's also important. I guess some of the things that we use the most are the percentiles and the quartiles. So in many cases, you are interested in knowing what is the percentile of that particular observation. But in some cases, you want to know what numbers, so what is the percentile of a particular number. So far we have done the mean, the mode, the median, percentiles, quartiles. So we also have these examples for percentiles. So if you want to do it, please feel free to do it. So, and then we have, going back to our mean, so just remember that we have this frequency distribution, right? So that is the first thing that we did. So we have a frequency distribution. Can we compute the mean of this particular frequency distribution? The answer is yes. We can compute the, what is this? Oh, so that was, hold on. So this was one of the examples that is, oh, this one. So this is the example that I did. I think I did it in here too. So we are looking at the presence of outliers. So in this case, 958,000. So is above the 639. So there is a present, the data set has an outlier. And as you can see, when you are using Excel, you don't have to arrange the data. It doesn't matter. So in this case, the data is, can be in any format. So going back to what I said before, so we have these cases. So also when we have group, when we have group data, sorry, not group data. Some of the measures of location and central tendency can be also the weighted mean, the weighted average. For example, when you take a class and your professor says, okay, 50% sampling learning, 25% your exams, 25%. So I'm gonna give you a score from 0 to 100, right? So, and then I'm gonna apply the weights. So in this case, the mean of a data set that is using weights is gonna be computed. So this is the sample mean, which is gonna be the summatory of all the observation, in this case, the score, times the weight divided by the summatory of the weights. So in many cases, the summatory of the weights are always equal to 1 or 100%, right? So weights are, for example, 50% for the mean for the test, 15% for the midterm, final 20%, so forth and so on, right? So I'm gonna give you a grade, and then I'm gonna multiply it for the weight, and then I am gonna add all these things, and that is gonna be your weighted mean. So in this case, did I make this case here? I guess, yes, I did. So we can do it in Excel very easily. So we have another case here, hold on. So let me see if I can type it very quickly. Variation, I guess. It's another. Well, we can do this case. For example, well, let's do the two of them. So so what happened is we have, oh, this is the weighted average. So hold on. So mean of group data. So I didn't do the weighted average, but you can do it very easily. So in this case, you are applying weights. So let me do it faster. So I don't like my small screen, but that's the only way I have. So I am going to type here. So this is the score. This is going to be the weight. So this is going to be the multiplication of X times W, right? So that's what we are doing here. So this is the test mean. This is the midterm. This is going to be the final exam. This is going to be the computer lab. And that's going to be the homework, right? So the scores are going to be 86, 96, 82, 98, and 100. So it's very common that sometimes students tell me, Professor, I got 100 on my homework. Yeah, but the weight that we give to this was only 5%. So this is 10%. So this is 20%. This is 15%. And the last one is 50%, right? So we have these values. If I add all of them, very likely I'm gonna have 100%, right? So I do the summatory, so I have 100%. So my formula tells me multiply X times W. So I'm gonna do that. This is gonna be 86 times the weight. So I am going to scroll this down, and then I am gonna add. So in this case, this is X times W. I want the summatory of the X's times the W's, and then divide this by the sample size, right? Or the summatory of weights. So in this case, the summatory of weights is 1. So what I'm gonna do here is I am going to sum all of them, all of these. So the final grade is gonna be equal this number divided by the summatory of the weights. So as you can see, I don't need to do that because it's always divided by 1. So my final score is 88.6. So in order to get an A minus, at least you need 90 points. So students come to my office and say, Professor, I have 100% in my homework. Yeah, but that is only 5% of the grade. So so this is very also, we can find many applications for the weighted mean. So also, that's what I was getting a little bit, not confused, but a little bit ahead. So we can also find, so if you remember our, so let me read this. So we also can find, so you remember our frequency distribution table. So we can find the mean value for this. So as part of the homework that you have to do, so I'm gonna do I'm gonna do the mean of the frequency distribution of the example, but I want you to find here, find the, here to find the mean and the standard deviation of the of this group data. So I'm going to show you how to do it, but as part of your assignment, you have to figure out how to find the mean and the standard deviation of this group data. So what we're going to do is the following. So so let me get so in order to find the group, the mean of the group data or group frequency tables, so we have to use this formula. So the summatory of the F's times the M. So M is the mean, the midpoint. And if I multiply the frequency times the midpoint and then divide it by the sample size, I'm gonna get the mean value, right? So in this case, remember, I need the frequency and I need the midpoints. So in this case, so let me raise this. So I have the frequencies. So if I multiply the X times the F, I'm gonna get the summatory of them, and then I am gonna divide it by the sample size. So this is the mean value, right? So what we're gonna do is we're gonna find the midpoints. Remember, midpoints are the average of these two values, right? So we are gonna find the average of these two values. In this case, I have to do it by hand because those numbers are not a simple cell. So I have to type them. So 19 plus 30 divided by 2. So this is the second midpoint. Then 31 plus 42. So I am adding these two numbers, right? Divided by 2, then equal 43 plus 54 divided by 2, then equal 55 plus 66 divided by 2. So once again, the last one, or no, almost the last one, 66 plus 78 divided by 2, and then equal 79 plus 90 divided by 2. So I have the midpoints here, so I can easily multiply, as it says, the midpoint times the frequency, right? So once I do this, I'm gonna drag this down, right? So I am gonna find the sample size. I just go to the sigma. So I have 50 observations in my database. So I also find the summatory of these numbers. So that's what my formula is telling me. It says multiply the frequency times the midpoints and then add all of them. Once you add all of them divided by the sample size. So, so I'm gonna add all of them, and then I'm gonna divide my summatory by the number of observations. So that is my mean value for the group data, okay? So we found the mean value very easily. And that was for the weighted average. So you can say weighted average, okay? So we have this. Okay, so we have the mean value for group data. So what I said before, please, in the frequency distribution table, identify the frequency and the midpoint and find the mean value, okay? So what else? So we have the average, the mean, the mode, the median, the quartiles, the percentiles, the weighted average. So, so this is the example I just did. So, you can do it again. So this is very nice also. So when we were looking at the percentiles and the quartiles, so we did this very nicely. We found quartile 1, quartile 2, quartile 3, and remember quartile 4 is also equal to the maximum value. So all I have to do is to find the minimum. So in order to find, so I can find quartile 4 by doing the quartile formula, or I can say equal maximum. So in this case, I want to find what is the maximum value in my data set. Of course, I know it here because the data is already organized. So it's gonna tell me what is the largest, but also can tell me what is the minimum value. So I want to know what is the minimum. Once again, this is just for practice because we already know that the minimum value is 18, right? So as you can see, if I find the minimum, the maximum, quartile 1, quartile 2, and quartile 3, that is called the 5-point summary, right? So this is the 5-point summary, which is very interesting and useful. So you want to know some data, very quick data on your, some quick information on your data, so you can identify the beginning, the end, and the data in the middle. So that is very helpful. So we also said that we can do this box plot, which is called the box and whiskers. So of course, this is a box and those are the whiskers, right? So let's do this using the data that I did here, right? So I am gonna ask Excel to create a box plot, right? So format is in insert. So what is the charts? So we're gonna do a box and whiskers, right? So we did kind of like this. So as we can see, so all the data is almost in this range. So we have houses that are cheap, and I think one of the houses was 1 million. So, but also we have a point that is way above our distribution. So this box and whiskers is telling me that very likely, almost eminent, this is an outlier, right? So so that's what we can do. So these box and whiskers are also a very good way to show or visualize the data. So the box and whisker gives a graphical image of the concentration of the data. So they also show how far the extreme values are from most of the data. So this is the 5-point summary that you can see in your box and whiskers plot. So you have the minimum value, you have the maximum, once again happens to be quarter 4. So the whiskers are telling you whether if one is longer than the other, or the two of them are longer, probably, well, no, very likely one of them is gonna be very long. So most of the data is gonna be happening between quartile 1 and quartile 3. So, and what divides these quartiles are the data, this line. So in many cases, the median might be leaning towards the right or the left. So that tells you a lot of information about your data. So you have the minimum, quartile 1, the median value, which is quartile 2, quartile 3, and the maximum, which is the highest quartile. So, and it seems that we're getting close to the end. So I'm gonna spend the last few minutes just talking a little bit about the distributions. So we can have distributions when we are building our histograms. And as I said, those histograms are very important because what we can see is the shape of the distribution. And this distribution happens to be very nice because the tallest bar happens to be in the middle of the distribution. So it seems that this is very symmetrical, as we can see, right? So the histogram displays a symmetrical distribution. So a distribution is symmetrical if a vertical line can be drawn at some point in the histogram such that the shape of to the left and to the right are almost mirror images. So this is a perfect symmetry, as we can see. So in this case scenario, the mean, the median, and the mode are all exactly the same. So we can have some cases like distributions that are skewed. So in this case, this is a skewed left. It's also called negatively skewed. So that means that the tail goes longer or elongates to the left. So when we have this kind of distributions, of course, that is different from this. So that seems that the tallest bar are going to the right. So the tail in the left is longer. So in this case, the mean is higher than the mode. So notice that the mean is less than the median. They are both less than the mode. So this is an indication that this distribution is skewed to the left, or is skewed left, or is negatively skewed. So we also have this histogram that is positively skewed, or skewed to the right, or skewed right. So the mean is the largest, while the mode is the smallest. So, so that is very important, because in most of the cases, and we are going to see that, we are going to be using this kind of symmetrical distribution to make strong assumptions about our data. So we also, we already look at the range. And so remember, the range is the difference between the maximum and the minimum. So we did it in the first case, so we can build the formula very easily. So we also are going to be looking at the deviations. So the deviations is the difference between the data entry and the mean of the data set. So we have deviations for the population. So that deviation is going to be the difference between the observation and the population mean. When we are using samples, the deviation is going to be given by the data entry minus the sample mean. Okay, so I'm going to do this very fast. I guess you can lend me 2 minutes. So I just want to give you some of the codes for this, and I think it's going to be, so we are going to be out of here at 7:32, okay? So we already mentioned that we can find the mean. The mean is going to be equal to the average of my data, right? So, so I have this database. I want to know the mean. I want to know the median. We already know those values, those codes. So, and as you can see, you are going to find differences between the mean and the median. So all this data is ages of students, and suddenly you ask your professor, how old are you? He says, I'm 65. Also the mode. So in many cases, we don't have modes, or if there are too many, Excel basically says, I don't know. So that's the reason. Oh yeah, 20 is the mode. So I was mentioning the deviations. So in this case, we have the mean, right? So we have the median and the mode. So the deviation in this case is going to be the observation X minus X bar, right? So in this case, I'm going to do the following. I'm going to do equal. So my observation is X is 20 minus the mean value, right? So I'm going to find how my observation deviates from the mean. So that's what we're going to do. In this case, this number is going to be negative, of course. 23.75 is greater than 25. So I'm going to make a little trick here. I think I mentioned that before. I'm going to use a $sign telling this computation that every data point is going to be subtracted by the mean. So these data points are going to be changing as I go down, but the mean is going to be exactly the same. So I want to make this cell fixed. So I build my formula. So I'm asking Excel, whatever is here, subtracted from this single cell. So I'm going to click this. So my deviations, as you can see, are here. So how do I know if I did a good job? Well, the sum of all the deviations have to be equal to 0. So I'm gonna click in the summatory, and I have to get 0 in this point. Okay, so we are gonna be using these deviations a lot in the next class. So so I need to stop because, as I said, when I start talking, I very likely cannot stop. Is there any question?
Yes, Professor.
Yes, please tell me. Tell me everything.
About the Excel work, I don't know where you're gonna post it. Is it gonna be on Blackboard or the on the other website that we have to use for the homework?
Very good question. That's a very beautiful question. So let me do the following. So this is module 1. So if you go to this descriptive statistics, so we have here. So I'm gonna add here a Dropbox. So it's gonna be upload your Excel assignment. So how much is this? I guess I said 5 points, right? So we are gonna add 5 points to this assignment. And then that's it. So you are gonna have this Excel assignment. Let me even put it on top of this so you don't miss it. So when you click here, you are gonna be able to upload your, so here, browse your computer and upload your file, okay? Thank you for asking.
I'm asking on Blackboard, where would we access the Excel work exactly?
Here. So if you go to module 1, go to chapter 2, and then this is the Excel file that I am explaining. I send it via email, I send it with the PowerPoints, but they are also here in each module. So at the end, you have to wait because we're gonna do chapter 2 and 3. So all the Excel file is gonna be bigger and bigger.
So you're gonna say when it's gonna be due?
It's gonna be due by September 17th, September 20th. It depends if you are observing the holiday. I think it's Rosh Hashanah. Many people don't, well, especially if you are following that religious holiday, people don't do anything but the religious part. But my point is, the point I'm gonna make is due on the 17th, but both Sapling Learning and Blackboard are gonna be open until the 20th, okay?
Okay, thank you.
So you have until the 20th, and just want to clarify, the deadline is the 17th, but because of the religious holiday, I'm not supposed to give any assignment during these days, but I'm just leaving open those Sapling and Blackboard for convenience, okay?
Okay,
so sure. So we are gonna be doing this, so we have still 2-3 more classes. I will try to be more precise, and I will try to be shorter. So we have a lot of material to cover during the semester, and I really want students to learn these topics because you are working in economics, so you need to do this, okay? So I'm gonna stop the